Right, so today we're going to continue looking at tree diagram questions. These ones are the slightly more challenging questions and are typically the ones without replacement, and you'll see what I mean by that in question 2. So to begin with, it tells you that Ben and Tom take a driving test. It says the probability that Ben passes is 0.8. We know that probabilities always add up to 1, therefore the probability that he will fail is 0.2. And for Tom, passes 0.7, so the probability that he will fail is 0.3. Tom just needs to be repeated below because the probability will stay the same. So part B then asks you for the probability that both will pass their driving test. So we have to find a route which means that both Ben and Tom pass. There is only one way of doing that in our tree diagram, and we remember to go from tree to tree we always multiply. So therefore our probability will be 0.8 times by 0.7, which is equal to 0.56. So part C, it asks you to work out the probability that only one of them will pass their driving test. So if Ben passed, Tom would fail, or if Ben failed, Tom would have to pass. So we have two different ways of achieving that goal. We have Ben passing times by Tom failing, which is 0.24. We have Ben failing times by Tom passing, which is equal to 0.14. If we now combine both probabilities, we would get our final answer of 0.38. The reason we add them is because we have two different ways of achieving the same goal. Therefore it is more likely, so you add them together. Question 2 tells you that we've got 3 red and 5 green sweets. He takes at random and eats it. So that is key here, because that is what tells you that those sweets do not get put back into the bag. Therefore our probabilities are going to change on our second tree diagram. So we start off by drawing our tree diagram. We have red and green, red and green, red and green. Our first tree diagram is our first pick. Our second tree diagram is our second pick. We can now fill in our probabilities. So we know there are 3 red sweets out of a total of 8 in our bag to begin with, and 5 out of 8 are green. If he picked a red sweet to begin with, there is then 1 less red sweet in the bag because he's eaten it. So there's then only 2 left out of 7. But if he picked red to begin with, he hasn't changed the amount of greens. So that is still 5 out of 7. Just do a quick check. Does that still equal to 1? Yes, it does. 2 sevenths plus 5 sevenths is 7 sevenths, which is equal to 1. So if his first pick was a green, that doesn't change the amount of reds he had, so he'd still have 3 out of 7. And if he picked a green to begin with, that means he's got 1 less green, so 4 out of 7. Again, double check, does that add to 1? Yes, it does. So to finish this question, it wants the probability that he takes 2 red sweets. So that must be red and red. Remember, we times to go from tree to tree, so this becomes 3/8 times 2 sevenths, which is 6/56. We can then simplify to 3/28, and we've completed our question. Our next question. Again, we have started with 10 counters. 6 are white. The counter is taken and not replaced. So again, that is key here, that it's not being replaced. So we're going to start by drawing our tree diagram. We have white and not white. So 6 out of 10 are white, therefore 4 out of 10 are not white. We can then continue this for our second pick. So we again have white and not white. So if we picked a white to begin with, that means there's 1 less, so it would be 5 out of 9, and it doesn't change our non-white counters. If we picked a non-white, we would have the same amount of white counters, but we would have one less non-white. Again, just double check that they add to 1. Now it wants us to calculate the probability that only one of the two counters is white. So we could go white and not white. And there's a second way, we could have a not white counter followed by a white counter. So there's two different ways of achieving that goal. So now we multiply our probabilities to go from tree to tree. So we've got 6/10 times 4/9, which is 24/90, and we have 4/10 times 6/9, which is equal to 24/90 as well. We can combine these together by adding them, and we get 48/90. We add them because it's more likely to happen because there is two different ways of achieving that goal. So our final answer would be 48/90, which you could simplify to 24/45. Right, so in question 4, the question's slightly more challenging as you have been given 3 different options. So I've pre-drawn this for you so you don't have to watch me draw each part. But we have plain chocolate and currant biscuits, and then on our second tree we have the same 3 options. Make sure you draw this big enough in your exam so that you can write down the fractions without it getting too complicated. So we know that she has 12 plain biscuits, therefore our probability is 12 out of 20 because there's 20 in total. We have 5 out of 20 chocolate and 3 out of 20 currant biscuits. Then having a look at our second tree. If we had selected a plain biscuit, that means we have eaten one of those plain biscuits. It doesn't mention whether it's been replaced, so therefore you have to assume that it hasn't been replaced. So therefore she would only have 11 out of 19 plain biscuits. It doesn't change the amount of chocolate which are in there, so 5 out of 19, and then we've still got 3 out of 19 for our currant. Then, if we go for our chocolate first pick, we would keep the same amount of biscuits which were plain, so 12 out of 19. We would have 1 less chocolate, so 4 out of 19, and we'd keep the same amount of currant biscuits, which were 3 out of 19. Our final pick, if we picked a currant first, we wouldn't change the amount of plain. Our chocolate would stay the same, and we would have 1 less currant biscuit. So just double check that each tree now adds up to 1. Well, if we take the first tree for example, so looking at this tree here, 11/19 plus 5/19 plus 3/19 does give you 19/19. If you did that for every tree, you would see that they all add to 1. Now we can look at the question. So it asks for the probability that the 2 biscuits were not the same type. So there's 2 different ways of doing this. So you could work out all of the different ways that they were different, so not the same type. Or, because you know probabilities add up to 1, if you did 1, subtract the probability that they were the same, that is going to equal to the probability that they are different, i.e. not the same. So let's work out the probability that they are the same. That means we'd have plain and plain, chocolate and chocolate, and finally currant and currant. So 12/20 times 11/19 gives us 132 over 380. 5/20 times 4/19 is equal to 20 380, and then 3/20 times 2/19 is equal to 6 380. If we now add those probabilities together, you would get a total of 158 320ths, and we remember that we need to work out what 1 subtract that answer is. That would leave us with 162 over 320. Okay, so in our last question we're told that he's got 7 tiles. Again, this is a non-replacement question. So we can see that we've got 2 out of 7 are the number 1, 3 out of 7 are the number 3, and 2 out of 7 are the number 5. If you picked a 1 on the first pick, that would leave you with 1 less number 1. If it helps, you can cross it out. That tells you must have 1/6 chance of picking a 1, 3/6 picking a 3, 2/6 picking a 5. If we do exactly the same now, but pretending we chose a number 3 to begin with, that leaves us with 2/6, 2/6, 2/6, and finally do exactly the same but picking a number 5 leaves you with 2/6, 3/6 and 1/6. So I want you to first of all calculate the probability that they both have a number 1 on. So there's only one way of doing this, that's getting a 1 and a 1. We multiply to go from tree to tree, so therefore it would be 2/7 times 1/6, which is equal to 2 over 42 or 1 over 21. Part B asks to calculate the probability that the number on the second tile is greater than the number on the first tile. So if we picked a number 1 to begin with, we could either pick the number 3 or the number 5. If we pick the number 3 to begin with, that means we would have to pick the number 5, and if you pick the 5 first, there isn't a way of doing it. So now we need to work out the probability of each of those happening. So if we pick the 1 and the 3, it would be 2/7 times 3/6. If we pick the 1 and the 5, it would be 2/7 times 2/6. And if we pick the 3 and the 5, it would be 3/7 times 2/6. If we work each of these out, we would get 6 over 42, 4 over 42, 6 over 42, which then gives us a total probability of 16 over 42, which is the same as 8 over 21 simplified.